So in the first video, we looked at this example and calculated these percentages that I wrote off here to the right-hand side based on the empirical rule. And with the empirical rule, it was always estimations. So now that we have the z-table, what we can do is find more exact calculations. So we're going to revisit those and find kind of improved solutions that are more exact, which is typically the route we're going to go with these questions. We'll kind of avoid that empirical rule unless we're asked directly to use it. So this first one was looking at 32 to 48 inches. Now what you'll see is I made my scale on the bottom here in terms of z-scores. So instead of mapping where 32 and 48 were landing, because those values don't show up on the z-table, I want to think in terms of z-scores. And from that previous example, we talked about how we were one standard deviation below and up above. But if we weren't sure exactly where we were landing, what we would do is our calculation for z-score. So taking like that 32 minus the mean divided by standard deviation, and that would give our -1. So we could get those exact spots where we're landing, which is typically what we'll need to do in the future as well. But for right now, since we've already visited these problems, we can just kind of skip the calculation part for the z-scores. So we're looking for the area between these two values. So with that, as we talked about in the previous videos, we need to set up our calculation a specific way. We need to find our large area to the left first. So what we're going to do is first find the area to the left of +1, which is 1.00 in terms of how we'll look it up on the table since we need to go to 2 decimal places. And then we'll subtract the smaller area to the left, which is going to be area to the left of -1.00. So with that, we're going to go to our table, which I've attached at the end here. So we're just going to scroll down and grab +1. So we have our +1, and then that last digit's a 0. So we're grabbing that 0.8413. And then what we'll do is grab the area to the left of -1. So we'll go to the negative part of our table and grab -1.00, which was a 0.1587. So when we take this difference, we should be landing very close to 68%, which in this case is a 0.6826. So a 68.26% chance is a much more accurate answer to this question that we were asked. Then what's the probability of more than 48 inches? So 48 inches was one standard deviation above, and we want the area to the right. And for area to the right, that's where we always have to use the complement. So going 1 minus that area to the left, and then we're looking at 1.00, which we've actually already found that up above there. So what we're looking at here is the 1 minus 0.8413. Which in the calculator would give us a 0.1587, which is very close to our 16%, but this is a much more accurate solution, 15.87%. All right, 24 inches of rainfall or less. So now what we're doing is we're looking out at -2. We were 2 standard deviations below average, and we want the area to the left. An area to the left is always just going to the table and grabbing the value directly. So what we're going to do is go to the table and find our -2. So we're at -2.0 and then 0, which is a 0.0228. So our 2.28% chance, which is nice and close to that 2.5% that we found from the empirical rule. 56 inches or less. So 56 was 2 standard deviations above the mean, and we want the area to the left. Which again, we just need to look up +2 on our table. So if we go to our positive part of the table, and now we want to look at a whole number of 2, with a 0.9772. So 97.72% chance, which is also very close to that 97.5% chance. Now, this last question before we couldn't answer with the empirical rule, we were stuck because we didn't have the z-table and we weren't landing exactly a certain number of standard deviations away, but now we can do this. So what we need to do first is find our z-score. So we're going to find our z-score, and doing that, the value they give us, that's going to be our x value. So we want to take our x value and subtract out the mean of 40 and divide that up by our number of standard deviations. So we'll take a 54 minus 40 and then divide it up by 8, which is a 1.75. Now, if you get more decimal places here, just always round to 2 decimal places with our z-scores, because that's how we have to look it up on the table. So with this, 1.75 is landing maybe about right here. And we want to find the area of that or less. So we're going to find the area to the left of it. So all you need to do is look it up on the table. So we're going to go to 1.7. So we have our 1.7. And then we want to go to where it matches up with the 5 for our last digit, which is happening here. So we're going to have this 0.9599. So we're looking for this probability that our z-score is less than or equal to 1.75, which was the 0.9599. So 95.99% chance of rainfall of 54 inches or less. And this last one that we did here with E is the typical route that we'll have to do, is find the z-score first. So you'll have your x value, your mean, and your standard deviation. And then once you find that z-score, use the table to figure out the area under the curve. So let's look at a brand new example. So we have here is a medical study of the population of children in Wisconsin, and they evaluated their cholesterol levels. And what they did is they found a mean of 1.75 and a standard deviation of 0.30. So with that, we have our distribution. They tell us it's normally distributed. So x is defined by a normal distribution with a mean of 1.75 and a standard deviation of 0.3. So a child has a cholesterol level of 1.63 milligrams. What is the percentage of children who have cholesterol levels that are lower than this child's? So what they're giving us here is a possible cholesterol level. And what we want to do is find a z-score because we want to move to our standard normal curve. So for our z-score, we take the 1.63 that was given to us, see how far away from the mean is that value, and then divide it up by our standard deviations. So 1.63 minus a 1.75 in the calculator, and divide that up by 0.3 will give us a negative 0.4. 0.40. So in terms of visually what we're doing here, again, you don't have to draw a picture, but I just like to, so I have kind of a visual for what kind of probability I'm expecting. So negative 0.4 is just a little left of 0, so we're over here. And then just to double check the direction we want to go, is that we want to go lower, so we want the area less than. So that's where we just get to go to the table and find the area to the left of this negative 0.4. So let's go to the table. We'll go to the negative part of it. And we're going to grab, we have a 0 for our one spot, and then a 0.4, and then a 0. So it's going to be a 0.3446. So in terms of answering this question, there's a 34.46% chance that their cholesterol level is lower than 1.63. In this next one, a child has a cholesterol level of 2.11 milligrams per milliliter. What is the percentage of children who have cholesterol levels higher? So this one, we're going to be going to the right-hand side, and then they give us our X value is 2.11. So finding our Z-score first, we take the 2.11 they gave us minus the mean over our standard deviation. So we plug that into the calculator, and that's going to be a 1.2. So visually what we're doing here is we're going to 1.2, which is over on this side, and we want to find the area to the right, which means in our calculation we'll be taking 1 minus and the area to the left of 1.2. So we'll have 1 minus, and then we'll go to our table and find our 1.2, and then our last spot's a 0, so we'll go 1.2, the 0 is 0.8849. 0.8849, and then we have to do our calculation of taking 1 minus that value. So plug that into the calculator to get a 0.1151. So 11.51% chance of that occurring. All right, and then this last one's looking between two values. So this case we have two X values. So we have our first X value and our second one. So with that, we'll need to get two Z-scores going. So our first Z-score, we'll take the 1.3 and then subtract the mean and divide by 0.3, and then plug that into the calculator. And that'll be a negative 1.5. And then we need our second Z-score, which will take the 2.23 minus the mean over the standard deviation and plug that into the calculator, which will be a 1.6. So with this, for our bell-shaped curve, we're looking from negative 1.5 up to 1.6, and we want to find the area between those two values. So what we're going to do is find that area that's left of 1.6 first, since that'll be the larger area, and then subtract area to the left of negative 1.5. So area to the left of 1.6, so go to our positive spot, and 1.6, the 0 is a 0.9452. Then subtract area to the left of negative 1.5 with a 0 is a 0.0668. So then carry out that calculation, and that's going to give us a 0.8784. So there's an 87.84% chance of being between those two values. So that's how we'll do calculations given some mean and some standard deviation, and then being asked about probabilities. Something I want to note here before we end this video is that all of these scenarios were the idea of being given cutoff values. So we're given the edges of the border for our shaded area under the curve, and then from there we found probabilities. What we're going to do in the next video is switch it around. What if we know the probability? What if we know the area under the curve and where are the cutoff values? So what's going to happen with that is we'll use the table in reverse. We'll search for the area and then from there find the Z-scores.